Okay, this is 9.3, perform reflections. We're going to be reflecting figures on a given line that's basically acting as a mirror. I got to go through a few definitions first. First of all, what is a reflection? Reflection is a transformation that uses a line like a mirror to reflect an image. It's very straightforward like that. You kind of have to use common sense with this. But the line of reflection, that's the actual thing that acts as the mirror. So it acts as the thing that is reflecting. So in this case, it's going to be a line because we're going to be talking about two-dimensional space. So you can have lines like y equals x, y equals negative x, y equals 3, x equals negative 1, those types of lines. So you have to be comfortable with graphing lines. Okay, so we have the vertices of triangle ABC are 1, 3, 5, 2, 2, 1, and I'm asking you to graph the reflection of triangle ABC as described in the line y equals 4. Okay, so in order to do this, you have to know what kind of a line y equals 4 is. Y equals 4 is a horizontal line, and you go up on the graph 4 spaces and draw a horizontal line. The next thing you should also do is to graph A, B, and C. Go right 1, over up 3, so on and so forth. So after you do that, you have to reflect it. And this is I guess, the tricky part of the whole thing. And all in reflections that you have to do is just count how far away from the line of reflection that you are. So this is our line, y equals 4. And all you have to do is just count using elementary counting properties to see how far away from the line of reflection that you are. So I am 1 away here. That means I'm going to go 1 away on the other side. For the B to the B prime, I'm 2 away here. That means I'm going to be 2 away on the other side. For C, I'm 1, 2, 3 away. So that means I'm going to be 1, 2, 3 away for the C prime. So reflecting it in a line that's either horizontal or vertical is actually pretty straightforward, pretty easy. Okay, what if I were to ask you to graph a reflection of triangle ABC in the given line x equals negative 3? So now x equals negative 3 is a vertical line. It's up and down. So what you have to do is you have to graph the vertical line, and using the points from the previous example, graph that and then reflect it. So what you should have, and I went by 2's in this case, just because it's a little bit easier sometimes when you have you change the scale, you can actually fit it on the graph. So if you go by 2's, you go up 2 or over 2, up 1 for the C, over 1, up 3 for the A, over 5, up 2 for the B, and then you see your line x equals negative 3. That's your mirror. That's going to act as your mirror. So you just count how far away from the line of reflection you are. So I'm 1, 2, 3, because remember we go by 2's, 4 away from the line. So that means I'm going to go 1, 2, 3, 4 away from the line on the other side. And do the exact same thing. 1, 2, 3, 4, 5, 6, 7, 8. That means I'm going to do 8 on the other side. 1, 2, 3, 4, 5, 6, 7, 8 to get to B prime. And the prime's a little hard to see here. So same thing for C prime. So all you're doing is just using elementary counting properties to get what the image versus pre-image is. Where it gets a little bit harder, but again, you're going to have these types of things on your quiz to use for your quiz. So you're not going to have to memorize these formulas, these equations. So if I had the point, let's say I had the point 2, negative 3. If I were to reflect that point in the x-axis, the image would become the opposite of the y value. So all I would do in my original point is 2, negative 3. I would just do 2. The opposite of negative 3 is positive 3. So if I reflected it in the x-axis, I would get the point 2, 3. What if I reflected it in the y-axis? Well, I would just take the opposite of the x value. So the opposite of the x value would be negative 2. And your negative 3 stays the same. The ones that are a little bit harder, because you have to know how to graph an equation of a line. Remember, the equation of a line, you have a slope and you have a y-intercept. So in this case, y equals x, your slope is 1 over 1, and your y-intercept is 0. So if I'm reflecting it, all you have to do is you have to switch the x and the y placement. So my 2, negative 3 would become negative 3, 2. And then after this, again, if you have the y equals negative x, your slope in this case is negative 1 over 1, because again, you're going to have to graph these on your two-dimensional xy axis, and then show the reflection. So all the reflection does is you switch the values, switch the placement of x and y, and then take the opposite of those values. So if I switch the values, I get negative 3, comma 2, but then I take the opposite signs, which means I get positive 3, negative 2, and that gives me the graphed image given from the pre-image of 2, negative 3. Okay, so let's get some application with this. So if I have the endpoints of fg, and f is negative 1, 2, and g is 1, 2, reflect the segment in the line y equals x and graph the segments and its image. So all I do is I see, okay, well, I've got the line y equals x. So what do I do with the points? So go back to here, y equals x. This rule here says that all I do is I switch the x and y placement to negative 1 for f prime and to positive 1 for g prime. And then you graph it. And you have to graph everything. So here's the graph. Here's the line y equals x because you start at 0, go up 1 over 1, up 1 over 1 to get to the next point. We graph our original f and g and make a segment. And since we had negative 1, 2, that became 2, negative 1. So we just switched the x, y value placements. That's it. Okay, so let's say we did this again, reflect the fg from example 2 in the line y equals negative x. So what do? Look at the rule in your notes. What do you do with the points? All you do is you switch them and take the opposite signs. So in this case, switch them and take the opposite signs. That means my f, negative 1, 2 would become negative 2, positive 1, because it's the opposite signs as well. And the g would become negative 2, negative 1 to g prime. So let's graph it, and this is what you would get. Again, you have to know how to graph y equals negative x. That's your y-intercept, up 1 to the left 1, up 1 to the left 1 to get to the next point. And as you see, we got negative 1, positive 2 becomes negative 2, positive 1. So they're the exact opposites. You switch them and the opposites. You do the exact same thing for g to find g prime. So all you have to do is you have to know how to use the rule. You don't have to memorize the rule. Okay, so let's do this. You have two graphs on the bottom part of your notes. What I want you to do is I want you to graph A, B, C, and I want you to reflect it in one of the graphs in negative x and one of the graphs in x. You can pause the video, try this, and then check and see if your answer is correct. So what I did is I did my y equals negative x, which is this line here, and I had the point 1, 3. So the point 1, 3 here, since I'm doing it in y equals negative x, means I switch it, 3, 1, and take the opposite signs. So negative 3, negative 1. So negative 3, negative 1 gives you here, and you do that to all of them, switch them, and take the opposite signs, and you basically get this figure here, 1, is reflected to this figure here, 2. Now this guy here is a little bit tricky just because he's basically reflected onto himself. So we have the line y equals x here. The slope is 1, up 1 over 1 from the 0, 0 from the origin. My a value, when I plot it, my a, b, and c are my original points, and for y equals x, all you do is switch them. So the a would become 3, 1, and if you notice, 3, 1 is actually where c was. And so when you do this, it's basically mapping it onto itself. This guy goes over here, and this guy comes over here. So it's reflected onto itself. But the prime notation is an important thing. If you notice, the actual points do change in a couple places except for the B. But you need to make sure you dictate that or notate that with your proper prime notation. Okay, so we have apply composition of transformations. This is going to be a combination of two or more transformations. And we're basically combining 9.1 and 9.3 into one composition. So composition is a result of two or more transformations that are combined to form a single transformation. So the one that we're going to focus on is something called a glide reflection. And a glide reflection, all it is a 9.1 translation and a 9.3 reflection. And you do this on the same graph back to back. So we have a translation that maps your original point P to P prime. And then once you've done that, maybe it's 1 point, maybe it's 3 points, maybe it's 4 points, so on and so forth. Once you've done that to the P prime, you're going to do a reflection in the line that's parallel. It will always be parallel to the direction of the translation that maps P prime to a P double prime. So again, all we're doing is just doing 9.1 and 9.3 in one graph. So let's see what we got. So we have the vertices of triangle ABC are A 3 is 2, B 6 3, C 7 1. Find the image of ABC after the glide reflection. So we're going to first do the translation. That's 9.1. And then after we do that, we do the reflection. So the translation, that means we're going to move each one of these x values to the left 12. And then after we do that, we're going to reflect it and use our elementary counting principle to count how far away it is from the x-axis. Or you can use the 4 rules. It's going to give you the same thing. So here's your solution. And what you see is your original figure in blue here. I move it 12 spaces to the left. So each one of the points is moved 12 spaces to the left. The x-axis is this axis here. And that's parallel to the line of reflection, or the line of the glide from the translation. So all you're doing is you're reflecting it across and using your elementary counting principles. So we are 1, 2 away here. That means we're going to be 1, 2 away here. And you do that with the B, and you do that with the C. Now the thing is, if you notice the prime notation, you have A, B, C becomes A prime, B prime, C prime, and the second time when you reflect it, that becomes A double prime, B double prime, C double prime. So I can see notationally that you do it twice. And that's basically it.